Okay, today's lesson is 1-2A because I'm only doing the first objective of analyzing graphs of functions and relations. So our first objective is using graphs of functions to estimate function values, find domains, ranges, y-intercepts, and zeros of functions. So the key part right there is that we are using graphs. So it's all about, can you read the graph and find the information that you need off of a graph? Okay, so to start off with, let's go look at an example because you're familiar. I know you're familiar with all these terms, so let's just go see what kind of problems that you're going to have to do. So first off, we're going to use a graph to estimate function values. So an investor assessed the average daily value of a share of stock over a 20-day period. The value of the stock can be approximated by this lovely function where D represents the day of the assessment. Okay, they want us to use the graph to estimate the value of the stock on the 10th day. Excuse me. So if we're on the 10th day, then I'm going to the number of days and I'm going to 10 and I'm going to go look up on my graph, and that's where my pink dot is. And so then I'm going to go across to my y-axis and say that's somewhere between 30 and 36. And I'm thinking that it is going to be V of 10 is going to be 32. So we're going to say that our stock is $32 on the 10th day. They ask us to confirm that estimate algebraically. So to confirm it algebraically, that ties into what we did on the previous lesson, and that's evaluating the function for V of 10. So remember, we're going to write the function rule, which is what is up here, okay, right up there. And everywhere we have a variable in parentheses, we're going to plug in 10. And when you simplify that, you find out that V of 10 equals 32. So we're pretty good at reading the graph. Now, one of the things that I want to point out to you, because, well, we'll go do the first one, the next problem first, and then I'll talk about it. Use the graph to estimate the days during which the stock was valued at $30 per share. So $30 per share is, I'm looking for dollars per share, so I'm looking for the 30 on my y-axis here, and 30 happens right there where the green dots are. Everywhere there's a green dot is where my function crosses 30. So it looks like I have 0, and then I have between 8 and 10, which is about 9, and between 14 and 15, between 14 and 16, which is 15. So I'm going to estimate that those days are 0, 9, and 15. They ask us to confirm that algebraically. So if you go plug in those numbers into your function, then you're going to get these numbers, which are pretty close to 30. Obviously, 0 is not. But what I want to point out to y'all is anytime you are given an equation, okay, that you can always plug in. If you have a graphing utility, which is what I'm about to show you, you can plug in that graph and get all of this information. So I want to do that for you real quick because we haven't talked about it, but I told you about it and you had it for the setup of the class, was to go to Class Calc. So if you either open a tab on your computer or open the app on your phone, generally comes up to Scientific. You come over to the right corner, top right corner, and we're going to click on Graphing. Okay, now notice that my function said V of D equals 0.002 D to the fourth. So the two variables I have here are V and D. Well, whenever you use a graphing utility, you always have to put that in terms of Y and X. So when I plug it in, I'm going to say Y equals, and I had 0.002, and instead of D, I have to put X. And you can either use the caret symbol above the 6, and then I come back down, minus 0.11x. Otherwise, you can come down here and press A to the end, and it will take you up there. If you're on a calculator, if you long press it, then it'll bring that up. So minus 0.11x to the third plus 1.77x squared. Come back down, minus 8.6x plus 31. And I wrote 32. It's supposed to be 31. Okay, so one of the things, you click this down, which you have on your phone as well. Click that down to get, there we go, comes down. There's a little icon right there that if you click on that, usually hones in on your graph. But if not, you'll scroll out and you will see your graph. Okay, so one of the things that I wanted to point out with y'all is that when we were looking at these values right here to find out what they are exactly, yes, we could plug them in algebraically, but also on a graph, you can come here and type in y equals 30. I don't know why he came up. Y equals 30, and when you do that, I'm going to change this color here. I don't want to do that. I want to change the color so it's a little bit easier to see. Okay, so now when I go zoom in here, you can see that it's not really at 30, but if I click on this and click on here, come on, there we go. It's giving me the points of intersection right there. So we had the days 0, well, 0.119, that's pretty close to 0. That's a tenth of a day. 9 days, and then 15 days. So keep in mind, class calc, we're going to use it a lot, and I just want to make sure you all know how to do that. Okay, the rest of our lesson today, and actually I'll tell you that I put that graph in here in case anybody is interested in seeing that. All right, go away. Now, the rest of our problems here, we have the graphs for you, but I want you to know in your homework, sometimes you won't have those graphs. So if not, you all have access to class calc and can graph them on a calculator or a graphing utility. Okay, so to continue, we are now use the graph of G to find the domain and range of each function. Okay, remember domain refers to our X, and when you're looking at a graph, you're looking at the farthest to the left and farthest to the right. Range corresponds to Y, so I'm looking at the farthest down all the way to the lowest to the highest, or you're looking up and down on your graph. Okay, we always want to give these numbers in order. Okay, so to start off with my domain, I'm going to go find my domain and my range. So my domain is left to right. What is farthest to the left is this dot right here, and that is -2. And what's farthest to the right is +2. We have a closed circle, so I'm going to have a bracket. Open circle, so I'm going to have a parentheses. Range, my lowest point, I'm looking up and down. My lowest point is 0, and my highest point is 4. Now, there is no open circle up here at 4, so you can assume it's closed, and it can equal 4. Even though this one is open, that one is closed, so it can be equal to 0. So we go from 0 to 4, both of those with brackets. Okay, look at the next one. We have, we're going to look for the domain and range again. So again, I'm looking left and right. Farthest to the left is this point, -4. And then I go, and I'm still at this spot, and then I keep on going, and it goes on forever and ever. So my farthest to the left is -4. Farthest to the right is infinity, -2. So remember, see this point right here? I forgot about that. It doesn't equal the function. So that's why I cannot include 2 in my answer. If one of these two was closed in, then we would be able to go from -4 to infinity. So because I don't have it closed in, then I have, this is how I say it goes everywhere from -4 to infinity, but it's not defined at 2. Okay, range, up and down. I'm looking for the lowest one first. Well, I have an arrow going down, so my lowest point is -2. And then it goes all the way up to this point. My lowest point is -infinity. And then it goes up here to -2. Okay, but then it jumps, and there's nothing in between here until I get to here, which is at 6. So this is how we write it. We go from -infinity to -2, and then we go to the number 6. And it's equal to 6, so there's a bracket around that point. Okay, so that's your domain and range. Now we have y-intercept. Okay, how do I find a y-intercept? What is the y-intercept? The y-intercept is where it crosses the y-axis. How are we going to find it algebraically? Well, that's when we plug x equal to 0. Okay, so I put a dot right here. Excuse me, I put a dot on the y-axis because that's where it crosses. So it looks like my y-intercept is 0, 4. So I put 0, 4. They want us to find it algebraically. So I'm going to come down here and I'm going to go put in f of 0 and plug in 0 everywhere. Or you can just ignore the x's every time you see it. So f of 0 is 4. So my y-intercept is 0, 4. So remember, we always plug in 0. So when you write the y-intercept as a point, it's 0, 4. If they ask, sometimes a problem will say, what is the y-intercept? You can say 4, but you do not want to say y equals 4 because y equals 4 is a horizontal line. Okay, look at this next one. Looks like my y-intercept is, well, I'm going from 0 to 4, so this second tick mark is 2. So it's somewhere between 2 and 4, but it's less than halfway, so I'm going to go with 2.5. Okay, it's an estimate. So that means it would be 0, 2.5. Again, I'm going to go put in f of 0. So 0 squared plus 6. Again, you can do that on class calc. I'm looking for the square root of 6, which is 2.449. Close enough to 2.5. Okay? If you want to change it, then that's fine. Okay. Last problems. Use the graph of each function to approximate its zeros. Then find the zeros algebraically. So the zeros, are the x-intercepts. So we had the y-intercepts, and now we have the x-intercepts. Find the 0 algebraically. Well, this time we're going to actually take the function and set it equal to 0. So when you find the y-intercepts, you plug in 0. When you find the x-intercepts, you set it equal to 0. So looking at, that's the next part. So I'm looking for the x-intercepts. I put the orange dots on this one. And so it looks like I have 0, 1.3 maybe, and 2. Okay, those are my estimates. So now I'm going to go solve that. I'm going to take my function, 3x cubed minus 10x squared plus 8x equal to 0. And I'm going to factor. First, I'm going to factor a GCF. And then I'm going to remember how to factor trinomials. And if you need help, come see me. I'll be happy to help you with that. Then you set each factor equal to 0. X equals 0. 3x minus 4 equals 0. X minus 2 equals 0. And so x equals 0, 4/3, or 2. And in case you didn't know, 4/3 is the same as 1.3. So it was a pretty good estimate. All right, last problem. H of t equals the square root of 4t plus 1. So here's my graph. There is my x-intercept, which is also the 0. So my estimate is that is negative 0.25. Good enough. So when we set that equal to 0, okay, remember when you have a radical in there and you want to solve for that radical, I'm going to square both sides of my equation. So that gets rid of the radical, and 0 squared is 0. Take the 1 over to the other side by subtraction, divide by 4, so I have t equals negative 1/4, which is negative 0.25. So that sums up the first part of 1.2. Stay tuned for the next part. If you have any questions, please don't hesitate to come see me or email me. Y'all have a great day.